Good morning, dear students. Today I will discuss and the topic name is the condensing plant and the circulating water system. This is the part of unit 2 and the subject name is power plant engineering semester 7th. This is the outline. Introduction of steam condenser, function of steam condenser, elements of a condensing plant, advantage of steam condenser, classification of steam condenser. First of all, before going on the main slide, what is the meaning of the steam condenser? Steam condenser, it is a device in which the steam is condensed to the water at a pressure less than the atmosphere. And the condensation can be done by the removing the heat from the exhaust steam using the circulating cooling water. During the condensation, the working substance changes its phase from the vapor to liquid and reject the latent heat. The exhaust pressure in the condenser is maintained nearly the 7 to 8 kilopascal, which is corresponding to current dish temperature of nearly 313 Kelvin. You know very well, in a thermal power plant, steam condenser is a very important unit. After the expansion of the steam in the turbine, steam will be condensed in the steam condenser, and it is very necessary because of the recirculation of the cold water and the hot water. It is necessary to the boiler. What are the function of the condenser? To reduce the turbine exhaust pressure so as to increase the specific output and hence increase the plant efficiency and decrease the specific steam consumption. This is the main function of the condenser. Because of the, if the expansion is reduced, if the expansion of the steam is done at the reducing or the vacuum pressure or the lowest pressure, this is the condition for the condenser for the fully expansion or the maximum work done is obtained when the reducing pressure expansion is taking place in the condenser unit, or the there will be a chances of the steam will be condensed into the liquid form. ये बहुत जरूरी रहता है कि एक्सपांशन जो टरबाइन या कंडेंसर में हो रहा है स्टीम का वो रेड्यूसिंग प्रेशर पे हो ताकि हम स्टीम को प्रॉपर तरीके से लिक्विड फॉर्म में ले सके। साथ ही साथ में प्लांट की एफिशिएंसी इससे बढ़ती है और स्पेसिफिक स्टीम कंजम्पशन जो है वो रिड्यूस होता है। To condense the exhaust steam from the turbine and reuse it as pure feed water in the boiler, thus only makeup water is required to compensate loss of water. इस ऐसा करने से जो आपका टरबाइन से निकलने वाली स्टीम है उससे अपना जो वाटर या कंडेंसेट बन रहा है उसको हम सप्लाई कर सकते हैं बॉयलर में और वो पूरी तरीके से प्योर फीड वाटर रहता है एंड जो भी आपको मेकअप वाटर की रिक्वायरमेंट थी वो पूरी हो जाती है। साथ ही साथ में हम वहां पे जो वाटर का लॉस हो रहा था उसको हम पिकअप कर सकते हैं या उसको अपन कंपनसेट कर सकते हैं। Enables removal of the air and other non-condensable gases from the steam, hence they improve the heat transfer. जितने भी एयर रहती हैं या नॉन कंडेंसेबल गैसेस इम्प्योरिटीज रहती हैं ये सब हम रिड्यूस कर सकते हैं या रिमूव कर सकते हैं जिसके कारण से कि हीट ट्रांसफर बढ़ जाता है। एलिमेंट्स ऑफ द कंडेंसिंग प्लांट कंडेंसर क्या क्या मेन एलिमेंट रहते हैं? एयर एक्सट्रैक्शन पंप, कंडेंसेट एक्सट्रैक्शन पंप, कूलिंग वाटर सर्कुलेटिंग पंप, हॉट वेल, cooling tower, makeup water pump, boiler feed pump. So this is the main circuit diagram. This is the elements of the steam condensing plant. Already you have studied in the thermal engineering gas dynamics subject. This is the basic element where the all the things are the clear. The condenser unit where the steam is coming from the external sources or the boiler side where the expansion is taking place in the turbine, and after that steam will passing through the condenser unit. So this is the condenser unit where the condensing of the steam taking place through the cooling water supply from the cooling tower. यहाँ cooling tower से cooling water की supply की जाती है cooling water pump के द्वारा। Steam which is coming through the external sources from the turbine. This is the external sources from the turbine. It is coming from the topmost side and from the condenser. When the condensation is it is done in the unit condenser unit, the condensate is supplied to the this unit or the boiler section. So where the boiler the steam will be condensed and reuse again and again. तो यहाँ पे जो आप देख रहे हैं कि आफ्टर द कंडेंसर जो भी आपका कंडेंसेट निकल के आता है उसको हम हॉट वेल में इकट्ठा कर लेते हैं और उस हॉट वेल से जो भी लिक्विड आपका इकट्ठा हो रहा है उसको बॉयलर फीड पंप के द्वारा बॉयलर यूनिट में भेज दिया जाता है। तो दिस इज द मेन फंक्शनिंग ऑफ द स्टीम कंडेंसिंग प्लांट and the water is supplying from this unit to the condenser part and after that air is extraction air is squeezing or the air is withdrawn from the air extraction pump. यदि कोई एयर आ जाती है बॉयलर यूनिट में तो उसको भी एक्सट्रैक्ट कर लिया जाता है। एडवांटेज, इट इंक्रीजेस द वर्क डन। वर्क डन जो है आपका पर केजी ऑफ स्टीम इट कैन बी इंक्रीज टू द पावर प्लांट। इट आल्सो रिड्यूसेस द स्पेसिफिक स्टीम कंजम्पशन, देयरफॉर द reduces the size of the power plant of the given capacity। तो जो पावर प्लांट की कैपेसिटी है या बोलना चाहिए जो साइज है फॉर द पर्टिकुलर गिवन कैपेसिटी इट विल बी reduce। इट इम्प्रूव द थर्मल इफिशिएंसी ऑफ द पावर प्लांट। कंडेंसर का इस्तेमाल करने से जो पावर प्लांट की थर्मल इफिशिएंसी वो बढ़ जाती है। It affect the saving in the cost of water to be supplied to the boiler since the condensate is returned to the boiler because of the condensate is carrying of the water, hot liquid. So that's why the supply of the water it can be reduced in the boiler unit, and therefore saving of the cost to be supplied in the boiler it can be also reduces. Cost of water softening plant is also reduced because of the pure feed water is available for the boiler because of the condenser unit. In a condenser unit, condensate is coming in the pure form, and this pure feed water it is available for the boiler unit. Classification of the condenser, this is the jet condenser or the mixing type. Low level parallel flow jet condenser, low level counter flow jet condenser, high level jet condenser, ejected jet condenser. These are the classification of the condenser, and this is the further classification of the jet condenser or the mixing type. Surface condenser or the non-mixing type, this is the downflow, central flow, inverted flow, evaporative type, and the regenerative type. Jet condenser, in the jet condenser, exhaust stream and the cooling water come in direct contact and mix up together. Thus, the final temperature of the condensate and the cooling water leaving the condenser is the same. This is the main functioning of the jet condenser. Such condensers are normally used for the small power units. It can be used when the cooling water is the cheaply and the easily available. These condensers are not usually employed since the condensate collected cannot be reused in the boiler because it contains the impurities like the dust, oil, metal particle in the condensate. So because of the jet condenser, it is using of the mixing type of the condensate or the mixing type of the cooling water and the exhaust system it is taking place. That's why the condensate is obtained after the condensing. In the jet condenser, it is not purely formed, it contains of the like dust, oil, metal particle in the condensate. Low level or the parallel flow jet condenser, this is the exhaust steam and the cooling water both flow in the same direction. This is the basic functioning of the low level parallel flow jet condenser. Wet air pump, it is used for the extract the mixture of the condensate, air and the coolant. वेट एयर पंप का जो इस्तेमाल होता है वो मिक्सचर ऑफ कंडेंसेट को एक्सट्रैक्ट करने के लिए, एयर को निकालने के लिए, कूलेंट को बाहर करने के लिए, उसके लिए वेट एयर पंप का इस्तेमाल करता है। दिस लिमिट द वैक्यूम क्रिएटेड इन द कंडेंसर अप टू द 600 mm ऑफ Hg। ये वैक्यूम जितना भी क्रिएट हो रहा है 600 mm Hg तक रहता है, यहाँ तक कर सकते हैं। This is the low level parallel flow jet condenser. In the picture diagram, exhaust system is coming from the top and side, condenser cell it is there, cooling water is supplying from their side. So when the exhaust system and the cooling water are mixed up, there the condensate is collecting from the bottom side, and the wet air pump for the collecting of the any type of the air which are having the moisture. This is the low level counter flow jet condenser. The cooling water is supplied from the top of the condenser and the steam from the side of the condenser. The water flow in the downward direction through a series of the perforated trays. Steam get condensate while it comes in the contact with the falling water. So in the parallel and the counter flow, it is a difference because of the parallel flow. It is flowing in the same directions of the steam and the cooling water, whereas in the case of the counter flow jet condenser, the steam and the water is flowing in the opposite directions and the water flow in the downward directions. The air pump always maintain the required vacuum in the condenser and introduce the cooling water to be lifted into the condenser up to a height of 5.5 meter. The excess amount of the condensate from the hot wells flows into the cooling pond by an overflow pipe. This is the main functioning of the low level counterflow jet condenser. So low level counterflow jet condenser, air extraction pump, cooling water, exhaust steam, baffles or the tray to break up the falling water, condensate, extraction pump, and the feed water to the boiler. It is coming from the this sump side, hot well, overflow pipe, cooling pond. These are the all the units which are cover the low level counterflow jet condenser. So here the water is coming from the sides because of the in the counterflow, the steam and the water both are flowing through the an opposite direction. So that's why the cooling water is supplying from the sides. The exhaust steam is coming from the sides, so that the condensation is taking place, and the condensate and the cooling coolant which are collecting on the sides, and if any air is present in the during the condensation of the cooling water and the exhaust steam, the condensate extraction pump or the air can be absorbing by the this pump. So passing of the cooling water, it is done by the baffles or the tray to break the falling water. Feed water to the boiler, it is supplying from this hot well sections, and the overflow of the water can be collected from the overflow pipe, and it can be collected in the again in the cooling pond unit. Condenser or the barometric jet. The condenser cell is installed at a higher height greater than that of the required, and the tailpipe more than the 10.33 meter length, it is attached to the bottom of the condenser. This allows the condensate and the coolant to be discharged from the condenser under the gravity action. Hence, a condensate extraction pump it is not required. The water from the hot well will not be able to rise into the condenser and the flood the turbine due to the vacuum pressure maintained in the condenser. This is the high level jet condenser. So because of the condensation, it is done by the passing of the cooling water and the exhaust steam in the high level manner. So that's why it is called a high level jet condenser. Ejected condenser. In this cooling tower, enter from the top of the condenser at least under a head of a 6 meter of the water pressure with the help of the centrifugal pump, and then it is passing through a series of the convergent nozzle, and finally it leaves through a convergent divergent nozzle. This is the main functioning of the ejector condenser. The non-return valve help in the preventing the rush of the water from the hot well to the engine in case of the cooling water supply. Momentum of the flowing water, which is used to remove the mixture of the condensate and the coolant from the condenser without the use of any extraction pump. This is the ejector condenser where the cooling water is supplying from the this side, and the after that it is passing through the this type of the convergent type of nozzles, जहां से कि इसको पास किया जाता है कूलिंग वाटर को, and the non returning valve where the extractions can be done of the air, it is taking place, and the convergent divergent nozzle after that कि पहले वो convergent nozzle से होके निकलता है जहां पे कि उसकी जो प्रेशर एनर्जी है वो कम हो जाती है, काइनेटिक एनर्जी बढ़ जाती है, एंड आफ्टर दैट उसकी काइनेटिक एनर्जी और फर्दर इंप्रूव करने के लिए हम लोग यहाँ पे कन्वर्जेंट डाइवर्जेंट टाइप के नोजल लगाते हैं, एंड द कंडेंसेट इज कलेक्टेड एट द बॉटम एंड साइड. This is the main functioning, and this is the also it is a special case of the type of condenser. Advantage and disadvantage of the jet condenser. Advantage, simple in design and cheaper. सस्ते रहते हैं, बहुत महंगे नहीं रहते, डिजाइन इनका सिंपल रहता है, फ्लोर एरिया जहाँ पे भी इसको लगाना रहता है कम जरूरत पड़ती है. डिसएडवांटेज की बात करेंगे तो कंडेंसेट इज नॉट प्योर, हैंस कैन नॉट बी रीयूज, लो वैक्यूम एफिशिएंसी, वैक्यूम एफिशिएंसी बहुत ज़्यादा नहीं रहती है, and in the surface condenser the exhaust steam and the cooling water do not come in the physical contact, rather they are separated by the heat transfer valve, hence the condensate remains pure and can be reused. This is the diagram of the surface condenser where the it is steam which are passing through the top and sides, and it is not directly contact with the water, and the water is flowing through the in these tubes. तो वाटर को जो है ट्यूब्स में फ्लो कराया जाता है, और जो एग्जॉस्ट स्टीम है इट इज कमिंग फ्रॉम द टॉप एंड साइड्स. तो प्लेट विच आर यूजिंग फॉर द दिस साइड्स, and the water outlet is coming from this side, water inlet of this sides. Vapor grate, this is the using for the swirling motion is providing to the condensation of the steam. It is taking place in the tube insides, and the condensate is collected to the bottom side, which are extracted from the pump manner. Downflow surface condenser, exhaust stream enter the top of the condenser cell and the flow downward over the water tubes. Water tubes are the double pass. The cold water flows in the lower side first and then in upper side in the reverse direction, which enables the maximum heat transfer. This is the downflow surface condenser. Exhaust stream which is coming from the top and sides. Number of tubes which are installed in the insides of the system where the water is flowing in the tube sides and the exhaust stream which are surrounded by the tubes. Air cooling section baffles are using for the providing the higher heat transfer rate, and the air or the removing of the air or the moisture which are carrying out by the extraction pump, and the condensate which is collected at the bottom and sides, and that which is are supplied to the boiler unit. The condensate which are supplying through the pump in the boiler unit, which are done by this place. Central flow surface condenser, the steam flow readily inward. The condensate is collected at the bottom of the cell from where it is taken out by the condensate extraction pump. The steam gets access to the entire periphery of the tubes and thus a larger surface area for the heat transfer which is available as compared to the downflow. तो downflow के comparison में थोड़ा सा central flow type का surface condenser अच्छा माना जाता है क्योंकि इसमें steam जो है readily inward आती है, condensate को proper तरीके से collect किया जाता है self से, और steam जो है यदि excess में हो रही तो entire periphery of tubes में surroundings में flow होती है, and thus a large surface area for the heat transfer is available. In the case of the central flow surface condenser, it is represented or depicted in this figure. So exhaust stream which is coming from the top and side from the turbine sections, and air extraction which are collected by the air extraction pump, and the condensate is also collected as usual in the downflow type of the condenser. This is also done in this here. The condensate is collected in the bottom side of the condenser. Inverted flow condenser, the steam enters the bottom of the cell and the air extraction pump connected at the top. This is the main fundamental about the inverted flow condenser. Steam flow upwards first and subsequently return to the bottom of the condenser. Steam जो है ऊपर की तरफ जाती है पहले और subsequently उसको bottom के side में उसको return किया जाता है. The condensate extraction pump which is connected at the bottom of the cell to extract the condensate. Condensate को collect किया जाता है through the bottom side. Evaporative steam condenser. This is the diagram where the evaporative steam done by the evaporator coil or evaporating coil. Moisture which is taking off of by this fan side because of the during the condensation process. Sometimes it will be required. Moisture will be removed from this condensation or the condensing part. So that's why moisture can be collected or the exhausted from the fan sides, and the makeup water which is supplying on the another side or the reverse side whenever the requirement of the cooling water is less for the condensing of the steam which are coming from the turbine units. So condenser units, condenser tubes which are moving through the sides where the hot water is going coming after the condensation, and the condensate which are collecting from this tube and the another end. So water, cooling water which are supplying from the another way. Evaporative condenser, the evaporation of the some cooling water provide a cooling effect, thereby steam condense. Steam to be condensed which is passing through the grill tubes, and the cooling water is sprayed over the surface, outer surface of the tubes. The evaporative condensers are the more suitable for the small plants where the supply of the cold water is limited. Evaporative condenser जो होते हैं, it is very suitable for the small plants where the supply of the cold water is limited. What are the advantages of the surface condenser? High vacuum efficiency, pure condensate, low quality cooling water can be used, and it allows the expansion of the steam through a higher pressure ratio. These are the advantage of the surface condenser. वैक्यूम एफिशिएंसी ज्यादा रहती है, कंडेंसेट बहुत अच्छी क्वालिटी का मिलता है, लो क्वालिटी का कूलिंग वाटर यूज कर सकते हैं, एंड इट अलाउ द एक्सपांशन ऑफ द स्टीम थ्रू ए हायर प्रेशर रेशियो. डिसएडवांटेज की बात करें, लार्ज अमाउंट ऑफ द वाटर इज रिक्वायर्ड, कंस्ट्रक्शन इज द कॉम्प्लिकेटेड, कॉस्टली, maintenance and the skilled worker are required for the case of the surface condenser. Larger floor area which are required in the case of the surface condenser. What are the differences between of the jet condenser and the surface condenser? So jet condenser, cooling water and the steam are the mix up. Require the small floor space. In the case of the jet condenser, the condensate cannot be used. More power is required for the air pump. Less power is required for the water pump. Require the less quantity of the cooling water. The condensing plant is simple and the less suitable for the high capacity plant due to the low vacuum efficiency. Surface condenser की बात करेंगे तो cooling water and the steam are not mix up, whereas in the case of the jet condenser they are the directly mix up. Require the large floor space area. In the case of the jet condenser, require the small floor space area. In the case of the surface condenser, the condensate can be used as a feed water to the boiler as it is not mixed up with the cooling water. Less power is required for the air pump. More power is required for the water pump because of the, in case of the surface condenser, because water is using as a from the cooling tower side. If the water is not supplying the proper quantity, there will be not proper condenser is done and not improving of the thermal efficiency. Require the large quantity of the cooling water. The condensing plant is complicated because of the this type of the surface condenser are using for the higher capacity. So that's why the large quantity of the cooling water is required, and the condenser plant that is a complicated manner. More suitable for the high capacity plant as the vacuum efficiency is high. What are the vacuum creation in the condenser? When the steam condenses in a closed vessel, the vapor phase of the working substance changes to the liquid phase, and thus its specific volume reduces to more than the 1000 times. Due to the change in the specific volume, the absolute pressure in the condenser falls below the atmospheric pressure and a high vacuum is created. This minimum pressure that can be attained depends on the temperature of the condensate and the air present in the condenser. The absolute pressure equal to the atmospheric pressure minus of the vacuum gauge in the condenser pressure. So this is the today lecture. If you have any doubt, please ask me.